go to Schoology and find the Chapter 16 Lesson 2 presentation, open that up, and log in and get ready to edit your copy. How do forces interact? Chapter 16, Lesson 2. Last week, we looked at how forces affect us. We talked about inertia, force, acceleration, velocity, and frame of reference. This week, we're going to look at how forces interact, and next week, we'll look at what gravitational force is. What is force? In physics, force is a push or pull on an object. A force can cause an object to accelerate, slow down, remain in place, or change shape. How is force measured? The unit of measure for force is the Newton, which is abbreviated as N. 1 Newton is the force needed to accelerate 1 kilogram of mass by 1 meter per second squared. The math formula is capital N equals 1 kilogram times mass divided by seconds squared. Other units of force include the dyne and the pound force. What is acceleration? Acceleration is the measurement of change in an object's velocity. When you press down on the gas pedal in a car, the car surges forward, going faster and faster. This change in velocity is acceleration. Acceleration also has a direction, which means it is a vector. Constant acceleration. When an object is changing velocity by a constant amount over time, this is called constant acceleration. An object with constant positive acceleration will be going faster and faster. Its velocity will be increasing constantly. Free fall, a type of acceleration. One example of constant acceleration is an object in free fall. During free fall, gravity applies a constant force on the object, causing a constant increase in velocity. If you were to measure the distance an object fell, each second it would fall further because it is constantly picking up speed. In the real world, however, there is a force that works against acceleration called air friction, and it limits the total velocity. And there is an ultimate total velocity, which we call terminal velocity, which is 122 miles per hour. Force, mass, and acceleration. Force can be figured out if you know the mass and acceleration of an object. This equation comes from Newton's second law of motion. Force equals mass times acceleration. Forces and vectors. Force not only has a magnitude, which is what we get in newtons when we use the equation above, force equals mass times acceleration, but it also has a direction. This makes force a vector. Vectors are shown by an arrow that indicates the direction of the force and a number that indicates the magnitude. Forces in equilibrium. Notice that in equilibrium, the prefix is equal, which looks a lot like equal. Sometimes there can be many forces acting on an object, but the object remains still. In this case, the forces are in equilibrium or balance. They're equal. The sum of the forces, or the net force, is 0. The picture below shows an object sitting on a table. The object isn't moving. This is because the force of gravity pulling the object down is equal and opposite to the force of the table pushing up. The net force is 0, and the forces are in equilibrium. Combined forces. When multiple forces are acting on an object, the resultant force is the sum of the vectors of the individual forces. Take, for example, a tug of war. The two sides are each pulling. If one side is pulling with a force of 2 newtons in the left direction, and the other side is pulling with a force of 3 newtons in the right direction, then the resultant force is 1 newton in the right direction. Types of forces. Friction. A force caused when one object rubs against another. It works in the opposite direction of the main force. An example of this is sand. Sand has a rough edge if you look at the particle, and sand particles will keep you from continuing to fall down if you lay down on it. But if you look at quicksand, they have rounded particles, so they don't slow you down and you can continue to sink. So that's why you should lay down on quicksand and float, because it's mainly water, and also the particles don't work against you. Gravity. A force caused by a large object, such as a planet. Tension. A pulling force that is exerted by a string, cable, or chain on another object. Elastic. A force exerted by an object trying to return to its natural length. Think of a rubber band being stretched. It is trying to return to its original size. Nuclear. A force that holds atoms and their particles together. Electromagnetic. Can pull or push, associated with magnetic and electric fields. Pause the video to watch the video called Floating Rice with Friction Experiment.